Good morning, students. I am Dr. P.S. Kaushik, Principal at Sri Digambar Institute of Technology, Dosa, Rajasthan. I am taking the subject Engineering Mechanics. This is my fourth lecture. This subject belongs to Civil and Mechanical branches for the third semester. Let us first learn what we have learned from the last lecture. Here we learn what are the fundamental laws of mechanics, what is force, what are its effects, what is conservative force and what is non-conservative force, and sign convention for tensile and compressive force. Here fundamental laws are the Newton's first law, Newton's second law, Newton's third law, the gravitational law, then principle of transmissibility, and the parallelogram law of forces. In last lecture, we explained the Newton's first law. We came to know the concept of inertia from this law. That is inertia. It is these laws are as good applicable for rectilinear motion as well as the rotational motion. Then we defined the force. We defined it as an agent which tends to change the state of rest or uniform motion of a rigid body. But in case of strength of material, we define it. It is an agent which tends to deform the body or deshape the body. In deshaping it, you will come to know when we will taking strength of material part of the subject that there will be a strain. To counter that strain, there will be internal resistance in the body. That resistance we will be calling it total stress. This total stress will be equal to the applied force. But when that total stress is divided by the cross-sectional area, then it will be called as stress or unit stress. Its unit is Newton per millimeter square. We will be going in details when we will be taking that subject there. Okay. Then we explained that to explain the force completely, its four characteristics must be explained clearly. What are the? Its magnitude, its point of application, its line of action, and its orientation or direction. We gave the example of a ladder to explain it. Then its effects, that displacement and deformation. Then conservative force and non-conservative force. We said that force is conservative if the total energy of the body does not change after displacement, and it will not change. For example, a body falling from a height, then the total energy contained at initial stage and the total energy contained after falling a distance will remain same, since that potential energy will be converted equally into the kinetic energy. Then we had a sign convention. Normally, the arrow pointing outward is called tensile force, but when we see from the body, then we can say the tensile force in the body will be marked like this. Then similarly, the compressive force will be marked like this. Now, in this lecture, we will be understanding the concept of system of forces. But before that, we should know what is system. It is to be noted that something is said to be a system when two or more identities are acting together to achieve a common goal or objective. For example, a classroom is a system. Here, students and teacher are part of it. Ultimate aim is to enlighten the student or about the subject we are going to teach it. Here, when two or more forces act on a body, they are called to form a system of forces or force system. Following systems of forces are important from subject point of view. The flow diagram below depicts that various force systems depending upon their magnitude, point of application, line of action and orientation. As I have told you in the earlier lecture, that these four parameters of a force will be defining that which type of force it is, what will be its effect and where will be its effect. Then coplanar force system, this is the first system. The force whose line of action lie on the same plane are known as coplanar force system. The collinear force system, the forces whose lines of action lie on the same line are known as collinear system. This is the system of forces. Coplanar force system, non-coplanar or spital force system we call it. This coplanar force system is further divided into concurrent force system, parallel force system and then non-concurrent, non-parallel system. Then concurrent force system is further divided into like forces, unlike forces. Then similarly non-coplanar or spital force system is further divided into concurrent system, parallel system, non-concurrent, non-parallel system. This is collinear force system. Forces F1 and F2 lie in the same line of action on the same line are known as collinear system. Then concurrent force system, the forces which meet at one point are known as concurrent force. The concurrent force may or may not be collinear. Current means you might have learned the current, the electrical current, water current. But when these currents, similarly you can have the concept of forces also. These forces when meeting at a point, we will call that these forces are concurrent, meeting at one point. Coplanar non-concurrent force system. If any one of the force of number of forces does not pass through the same point, then we will call it that it is a coplanar non-concurrent force system. Referring to the figure, the force F5 does not meet at the common point, that is of the other four forces, then this system has the category of coplanar non-concurrent force system. Then non-coplanar concurrent forces. For example, take the case of this tripod. These forces are concurrent, but they are not lying in the same plane. Then non-coplanar non-concurrent force. These forces neither meet at a point nor they lie in the same plane. For example, the force F5 lie in the XY plane. This then force F1 and F2 lie in the XZ plane. Then force F4 and F3 lie in the ZY plane. So these are the neither of these all 5 forces meet at common point. So these are non-coplanar, non-concurrent force system. Now, principle of physical independence of forces. If a number of forces are simultaneously acting on a body, then the resultant of these forces will have the same effect as produced by all the forces. So here the concept of resultant comes into figure, or we can say these forces can be replaced by a single force having the same effect as is produced by those number of forces together. The replacing force is called the resultant force. In details we will be going in the coming lectures on what is resultant force. Now, here one of the very important principle is principle of transmissibility. We call it principle because it is not universal, because this principle of transmissibility does not fulfill the requirements when body is deformable. So here the main important criteria is that body has to be rigid, otherwise it could have been law of transmissibility. As we have already discussed that force is completely defined by its 4 characteristics, that is its magnitude, its point of application, its line of action, and its direction or orientation. It is stated that when force is acting on a rigid body, that is first assumption of mechanics, then its point of application can be shifted without changing its effect on the body if its magnitude, line of action and direction are kept same, that is unchanged. In other words, the state of rest or uniform motion of a rigid body remains unaltered if the force acting on it is replaced by a force acting at another point on the body if its magnitude, line of action and direction are not changed. In the coming slide, I will be explaining it further. Note, it is to be noted that it is not a law but a theorem, means it has a limitation of application. This theorem is applicable only if body is considered as rigid. I have already explained earlier. This theorem can be proved by the method of superposition, as I explained next. Okay. Here, refer to the figure below. A force F1, say 50 Newton, is acting at point A in figure 1. And if in figure 2, two equivalent or opposite forces of same 50 Newton magnitude on the same line of action but at another point B are applied. Now, by law of superposition, we can cancel the facing forces, that is force acting at A and the force acting at B will cancel out each other. Then finally a force will be left at B, point B. Then we can say that we have shifted the force from point A to point B without changing its magnitude, line of action and direction, and the effect of this force on the body will be same as was earlier when it was acting at point A. Here the most important consideration is that the body is rigid. There will not be any strain developed in the body because we have considered it rigid. So here body, the function of body is just to transfer the effect of force from one end to another end. So here when it was acting at point A, it was pushing the body, but when this force is shifted to point B, it is pulling the body. But the effect of the force is same as was earlier. Now, thanks for watching this video. I will be taking the next video. In the next lecture, we will be dealing with some more conceptual fundamentals of engineering mechanics. Thank you.